Welcome to this edition of Let's Decode This Architecture. This is Rodriguez Manuel DeSilva with Cloud and Technology. Today's architecture to decode is shown on the screen. This is another submission by Jiju Thomas Mathew, an expert in architecting complex solutions on AWS. Scan the QR code displayed near his avatar image to find him on Google search. Today, we're exploring the architecture of a social game app backend deployed on AWS. This architecture is designed to ensure high performance, scalability, and global availability, providing users with a seamless gaming experience no matter where they are. Use case overview. Imagine a social game app where players can log in using their social media accounts, interact in real time, and store their game progress and achievements. The app needs to be highly responsive, handle varying traffic loads, and be available worldwide. To meet these requirements, we'll leverage several AWS services to create a robust backend architecture. Amazon CloudFront. First, let's talk about Amazon CloudFront. CloudFront is a content delivery network, CDN, that delivers any content with low latency and high transfer speeds. In this architecture, CloudFront will cache the static content of the game, such as images, CSS, and JavaScript files, stored in an Amazon S3 bucket. This caching reduces the load on the S3 bucket and speeds up content delivery to users around the globe. Amazon S3 bucket. Next, the Amazon S3 bucket with static hosting enabled. S3 is a scalable storage service which will store the static assets required by this game. With static hosting, S3 can serve these files directly to users. This setup ensures that the game assets are always available and can be quickly accessed by CloudFront for distribution. AWS API Gateway. Handling required dynamic content and game logic is provided through AWS API Gateway. API Gateway routes incoming HTTP requests to the appropriate AWS Lambda functions based on the request path and method. This service acts as the front door for our backend, effectively acting like an application load balancer, ensuring that each request is processed correctly and efficiently. AWS Lambda. AWS Lambda functions are the heart of this game app backend logic. Each path and method in the API gateway is handled by a different Lambda function. This serverless compute service allows us to run code without provisioning or managing servers, automatically scaling with the number of requests. This approach makes the architecture highly scalable and cost-efficient, as AWS only apply charges for the compute time that is consumed. AWS IAM Roles. Inter-process access controls for read and write on S3 bucket, DynamoDB, SQS and Cognito is suggested to be strictly controlled with least necessary permissions for service access. Lambda runtime assumes one assigned role and inherits the assigned permissions. AWS Cognito. For user authentication, this architecture suggests to use AWS Cognito. Cognito enables social login, allowing players to sign in using their existing social media accounts like Facebook or Google. It manages the authentication process, ensuring secure access to the game while providing a seamless user experience. Amazon DynamoDB Global Table. Stay tuned for more like this. Expect to be here every Monday at 9 o'clock with a new episode of Decode This Architecture. Thank you for joining us in this episode. Please do like, share, subscribe, comment to keep us going. Drop your questions if any into the comments.